Second part of my lecture is about the dimensions. As I promise you, I'm going to explain you about the dimension. Here, dimension of physical quantity is very important. Actually, the dimension, you can see the dimension about the dimension. Dimension of the physical quantity can be explained like this. The dimension of the physical quantity indicate the explicitly how the quantity is related through its defined equation to the fundamental quantities. We learned about the fundamental quantities. At that moment, we know how are they involving to form the equation, and the what is the weightage has been given, or they have been given by the fundamental quantity to form the new equation, or the relation is going to be discussed under the dimension. So here very important thing under the dimensional analysis, very important concept is going to be discussed by ourselves, right? Here basically I will get you some modern explanation about the dimension. It's very simple and very easy to remember. The definition for the dimension is the dimension of the physical quantity are the power to which the fundamental units of mass, length, and time must be raised to the express that physical quantity. That is the proper definition of the dimension. And here we can just discuss about that thing in this way. Basically, I said you dimensions not only M, L, T. Actually, capital letters are being using for this concept: mass, length, and time. M stands for mass, L, capital L stands for length, and T stands for time, capital T. Right, see here the dimensional symbols as I explained, but I said you there are more to be remembered in our studies. Then only we can just simplify the questions, examination questions. Now mass dimensional symbol is capital M, length dimensional symbol is capital L, dimensional symbol for time is capital T. As I said earlier, temperature is being given by simple, sorry, theta or K. And electric current, actually dimensional symbol is capital I O capital A. Luminous intensity CD, simple C, simple D. Amount of the substance that's small. Now those seven dimensions are really important for us. Basically, in our local A level system, we are giving the preference for M, capital L, and capital T for mass, length, and time, and trying to explain about the dimensions of the basic quantities, physical quantities. But if you can remember the other one, you can get marks easily. Now, see how do we just involving to find about the dimension of the physical quantity. Now you can see what the rules of that. I will enlarge it and I'll show you. Then very easy for us just to understand that one. Now look at this. We have to use square brackets to denote the dimension of. Example, dimension of v. How do you read it? Dimension of v, square brackets v, open square bracket v, close square bracket, equals to capital L t to the power minus 1. Indicates that the speed is measured by dividing the length. According to the definition, once again I will tell you the definition of the dimension. Dimension of the physical quantity are the power to which the fundamental units of mass, length, and time must be raised to the express that physical quantity. Now see, fundamental quantities as we learn, MLT, capital M, capital L, capital T are involving to form it, and there is a power. That means how do they involve for that? Look at this. By time, and F, dimension of force is a capital M, capital L, capital T minus 2, indicates that the force is equal to mass, time, and acceleration. The expression which represent the dimension of the physical quantity, example, how do we write it? M to the power A, L, capital L to the power B, capital T to the power C, also called the dimensional formula. This is known as the dimensional formula. Capital M, capital L, capital T to the power minus 2 is the dimensional formula. If you just use your brain, right? If you just use your knowledge of maths in diseases, right? Then we can just imagine and we can find the powers of capital M, power of capital L, and power of capital C. So here capital M raised to the power A, that means if you are comparing dimension for force, you can see capital M to the power 1 is available here, right? You can see that on, if you just discuss about this, you can see it very nicely. You can see it, just I'll use the red color, right? Just let's see it. Now look at this, to the power 1, to the power 1, and here minus 2. That means A, capital M, right, raised to the power 1. That means you can see A equals to 1. And in the place of L, you can see the power is 1. That means the value for B equals to 1. Likewise, we can see that one. And here T to the power C is available. That means here minus 2 is there. Obviously, we can say C equals to minus 2. That's very easy to understand. Right. See this dimensional formula. What is dimensional formula? This is the dimensional formula. It's called the dimensional. The dimension symbol of fundamental quantities are given in the table. It's very important for us. Just I will clear off those. I'll erase those things because those are really important for us to know how to find about the dimension fundamentally. Right. That's why I just brought it over here and I'm trying to show you. Right. Then let's use of the dimensional. Uh, let's see the dimensional formulae. Now this is the table of SI units and the dimensional formulae. If we can remember it, it's very easy for us to get the marks because our aim is to score the full marks accurately within very short period of time, especially in local advanced level physics paper. So we should not spend too much time on it. So if you can remember, that's very easy. The first you can see here serial number is there, quantity is there, SI unit is there, dimensional formula there are 1 2 3 4 4 columns are there. So over here volume, just SI unit is cubic meter. And the dimensional formula, remember it, you should write L to the power 3, or else this is the most accurate method. That means you have to interpret about the M and its power, L, capital L, its power, and the T to the power. Likewise, you can see there are lots of formula there. I will just show you. I will get you that thing after the explanation about this as a tutorial. Here, typical solved examples, really important. First example, let's consider about the first example and let's discuss about how are we going to obtain the answer for this. Now look at this example number 1, obtaining the dimensional formulae, that means plural form of formula is formulae of the following physical quantities. Number 1, universal gravitational constant capital G. Number 2, coefficient of viscosity neta. Number 3, Roman number 3, specific heat capacity, simple C. Roman number 4, thermal conductivity. Likewise, we are having 10. Those are really important and tricky. So how do you do the solution? How are we attempt to get the full marks for this question? It's very easy. Look at this. I will explain you in this way. In order to obtain the dimensional formula of the quantity, we use the equation or a formula involving the given quantity such that the dimension of the other quantity which appears in the equations are known. We then express the given quantity in terms of other quantities. Now, my dear students, actually, this comes under the first lesson in our studies under physics. So at that moment, we don't know the proper relationship between each and everything because we haven't completed the subject completely or syllabus completely. The person who has completed the syllabus, they will come to know because we learned all the chapters. So we know the relationship between each other. To avoid the difficulty in the first term, what we are doing is we have to remember about that list of the dimensional formula like this. I will get you that thing. You can just personally you can request that there is a number of mine, so you can send the SMS, or else sorry, you can send me the WhatsApp message. Just I will forward it, and other than that I will tell you the uh, notes are available. You can just have it from me. No worries about that one. I will get you those things. Very systematically I prepared it. You can just get it and you can buy that one from me. No worries about that one. Now see here the first very easy example: universal gravitational constant, capital G. So it comes under the field, gravitational field. So we know that one, the Newton's gravitational uh, formula will be given by capital F, attractional force between the massive bodies. Capital F equals to G, gravitational constant, product of the mass divided by the square of the distance. So what do they ask about? They are asking about the dimension of G. So subject G. Now this is the O level, simple O level maths. Then if you have done that thing mathematically, next step is just substitute the dimensional formula. The step is you should use the square brackets for that. Now can you see the square brackets we just use for the square bracket for G equals to square bracket for F, square brackets for R square, but there is a printing mistake. It has to have you here we have to write it as G, right? You have to use the square bracket, otherwise it's wrong, right? That says about the dimension of gravitational constant. F, F is a force. In future I will tell you force is a vector. We can use the vector notation, otherwise it's wrong. Then dimension of R squared, so you can just write it as R squared, right? Then it, those two quantities are dividing by product of mass, so you can write m squared, that means dimension of product of mass, right? That can be written as m squared, m squared, right? That's the way of writing it. Finally we can just substitute the dimension like this. Force, dimension of force is mlt to the power minus 2. Dimension of r squared is l squared, and divide by square of the mass will be given like this. Finally we can just simplify it. You will get this answer. I hope you can understand it. Here we are using some concept of mathematics, simple simplifications. Number one is you have to know about the laws of indices, right? There are laws of indices. Under that concepts we can complete it. I hope you have understood it. Then just I will clear this one. That's easy for us to know. Do more practice. Then Buddha, the next one, next part of mine is, now look at this. The next part of mine is about just I will clear this one. Excuse me for it. Right, you can see coefficient of viscosity. I'm going to discuss about three uh, question subtopics under this. Then I will just explain you very important concept over there. Now let's come for the Roman number two, coefficient of the viscosity. It's coming under the viscosity. So viscous force F equals to neta, coefficient of viscosity neta, area, and velocity gradient. dv, small change in velocity divided by small distance. So here what we are going to write is we want to subject neta, because we are going to find about the dimension of neta. So can you see we have done it. Here dimension of neta equals to dimension of F, dimension of L. There is a mistake. We should write this L within the brackets, square brackets, and A and this one. There is a small mistake. We have to be very careful with those places. Here there is a mistake. I will show you. The mistake is very, very dangerous one, because we are losing marks, right? So like this we have to have it. Then substitute the dimension. We know that dimension of F is mlt minus. How do you get this one? Once again I will explain you. It's very simple. Force equals to mass into acceleration. That is the That's coming under the Newton's second law. This is the expression for the Newton's second law, right? At that moment, if you want to have the dimension, you can just have it in very easy way. I'll use the brackets just to highlight the way. Dimension of F, dimension of force can be written as dimension of M, right? One more square bracket separately being used over here. It's very simple. Force, now you can see, equals to dimension of mass is, directly you can have write this as capital M. Then dimension of acceleration, right? Dimension of acceleration I will write in the another color, L t to the power minus 2. Otherwise, you will be surprising how did we get this one. Initially, you will get that one because while we are learning this concept, first you are getting stuck with the explanation. That's why I'm clearing it. Now, in place of F, we can write M L t to the power minus 2, all are capitals. Then the L is the length. Once again, length comes. Then area. Area means length into breadth. That is also breadth, also kind of a length. So we can have L, dimension of A is L squared. Then velocity, we know that one, velocity, displacement over time, dimension of velocity, you can just write it as dimension of velocity. It's very simple. Displacement, it's a kind of the length, right? Divide by time, dimension. Directly I'm writing the dimension. So this is called the fractional notation. You can just go for the index form, M capital T to the power minus 1. So that's why we got it as LT minus 1, right? Then afterwards, we have to use the knowledge, as I said, about the laws of indices. So here you can see M can be written as it is L. You can see here L to the power 1 is there, L to the power 1 is there. One more L is under means in the denominator. If you want, you can just cancel off this L and this L. Then directly you will get here L, right? Yes, there is a mistake. I hope M L t minus 1 L, right? Divided by L squared. Yes. You can see another L squared is here. That means here L to the power 1 is there. Those are in L to the power 1 over L to the power 2. That means according to the laws of indices, you can write it as 1 minus 2 powers. That means L to the power 1 minus 2, it comes as L to the power minus 1. Have you understood that step? Then we can go for the time. T to the power minus 1 is there. Here T to the power minus 2 is there. T to the power minus 2 in the numerator and T to the power minus 1 in the denominator. So simple simplification can be applied over here. Directly you will get it T to the power minus 2 minus minus 1. That means plus 1 comes over here, right here. It's very simple. I think you can understand. Minus 2 minus minus 1, that means plus 1. So sign rules are already there. Then finally we get it, we got this answer. I hope you can understand very easily of simplification. That is the important part of calculation. So you have to be a little bit quick on it, and you have to be make sure that your calculations are perfect. Just before I'm going to explain about the third Roman number 3, what I'm going to do is I'm going to explain a new concept under the same topic, that means under the dimension. So it's very important. If you are not knowing about those, to be frank with you, you will be in trouble. Trouble means you will lose lots of marks. This is a competitive exam. Uh, all the students, my dear students, have to be remember, we should not make mistakes over here. If you are making mistake means you can't get good marks. Now look at this. Here, what I am going to tell is use of dimensional analysis. Actually, why do you want to use the dimensional analysis? Use of dimensional analysis application. Actually, the first one is conversion of units. In the correct physical equations, the dimensions of all the terms must be the same. That's very important one. They are asking this property. This property is known as principle of homogeneity of the dimensions. Like terms can be added together or subtracted together. That's why they have explain. Actually, they are explaining it very beautifully in a correct physical equation. The dimensions of all the terms must be the same. I will explain you within another 2 3 minutes about this. This principle is based on the facts that only similar quantities can be added or subtracted, and leads to the following simple applications of the dimensional analysis. Actually, those are the application. First one, the conversion of units. Now you can see the conversion of units, right? How do we do the conversion of units? Consider physical quantity having the dimension formula m, capital M to the power L, L to the power B, and capital T to the power C. Let there to be says the terms of M1, L1, T1, and another set is there M2, L2, and T2. We don't know the multiplier. Let's say n1 and n2 be the numerical values of the quantities of two systems. Look at this. We can just express the equation like this. First system m1, sorry, we can just have it m1 as suffix, l1 suffix, t1 suffix, abc, but the powers are equal, but the suffix are different. So those are different quantities, and the multipliers are different. N2, n2. Right here you should write n1. Here there is a mistake. We can see it. Right, there is a mistake over here. This one should be n1. Right, n1. Now easily we can have that. Look at this, simple maths is going to be utilized. Right, so how do you do this one? Easily we can have it. Right, into is going to be subject. Then you can write m2 value, right? M2, L2, B2, because powers are equal. So this is very important. Here the ratios m1 over m2 ratio, it's a ratio. L1 over L2 is a ratio. T1 over T2 is a ratio. Their powers are A, B, C. Can you understand it? Just go through while you can understand it. It's the simplest and very easy concept. Right, then let's see what is going to be done over here. I'm explaining these things. It's very important and very easy to understand, simple maths. Now look at this. For conversion, now see, we learned about three systems of units. I said you CGS system, MKS system. Finally, I taught you about the SI system, and I discussed about the advantages of it. Now look at this to just get the relationship between mapping between the MK system to CGS system. It's given like this. Now look at this. M1 over M2 is 1 kilogram to 1 gram, because MKS means mass, a meter, kilogram, second. Here CGS means centimeter, gram, second. Once again, I will explain it in simplest way. It's very easy just to understand. Now look at this. Over here, M1 is the M means meter. Here kilogram, and this is second. This is now you can say meter and centimeter. You can see first system the length is measured in meter. In the second system the length is measured in centimeter. Then mass is going to be measured in here. In the first system they are going to measure the mass in kilogram. Simple K, simple G. Remember it. And the second system in gram. Now in our earlier mathematics classes, we learned unit conversions, and it is actually those questions were given us full marks. But here, that is a sub part. Now the third one you can understand. Second, time measured in second, and here also the second. No worries about that one. Actually, this is length. I'll write the dimension length. This is mass m, and this is time. I said you the definition twice before we are just going to discuss. Here you can see the length of the first system measured in meter, second system measured in centimeter, mass measured in kilogram in the first system, and second system measured in gram. Time are the same. Now look at this. What is the relationship between meter and centimeter? How do you convert centimeter into meter? 100 centimeter equals to 1 meter. Look at this. Length 100 second system is in centimeter. 1 centimeter, 1 meter. What is the factor? What is the ratio? 100. Can you see? 100. That is the ratio. Think about the mass, kilogram and gram. First system measured in kilogram, right? Second system measured in gram. Can you see this? Right. At that moment, see here, kilogram and gram. Then what is the factor? 10 to the power 3. Second, it's 1. Now look at this. How do you substitute? Now you can substitute the values over here. N2 equals to N1 times, right? You can see 10 to the power, because all are 10 to the power. M1 over M2, you can see it. M1 over M2. I'll scroll it bit. M1 over M2, right? M1 over M2 is factor is 10 to the power 3. We don't know the what is that called? Power or order. Let's write MA. M1 over M2 is 10 to the power 3. Power is A, right? 3, then you will get uh, A over here, right? Once again, I'll clear it. I'll write it and I'll show you. Otherwise, M1 here, I just substitute here. N1 is there, right? Here you will get M1 over M2 is 10 to the power 3, right? Close a simple bracket, and you can see there is a power. They mark the power as A. Just we wrote it as it is. In the second one, L1 over L2 is L1 over L2. The power is 10 to the power 2. Right? Then Buddha. In the formula, we can see the index or the degree is P. Can you see? And the third one, I'm changing the colors and writing for your convenient. You can see the answer is T1 or T1 to the power C. Now look at this simple mathematics. Here you can just write it N1 into 10 to the power 3a. Can you see? Simple mathematics. 3a into 10 to the power 10 to the power 2b. Then you can just use the knowledge. You can write it this expression 10 to the power 3a plus 2b, because the bases are equal over here and the powers are getting added up. That means finally you will get this relationship. Now have you understood this concept? It's very easy. Now this is the first property application of the dimensional analysis. It's very clear. Second dimensional analysis based on, just I will clear those, right? uh, Second concept is checking the correctness of the equation. Correctness of the equation. Now let's see. We have seen lots of equation in the maths as well as in physics. Let's see whether is it true or false. Third one, deriving simple relations connecting physical quantities, providing all the quantities which are certain quantity depends are known. We shall elaborate these applications in the solving examples in future. I'm going to discuss those things separately. Now, after learning the applications of the dimensional analysis, the last part of that is under the theory's limitation of dimensional analysis. There are some failures, disadvantages. Let's discuss one by one. It gives no information about the dimensional constants. Now some constants being using over there, but at that moment they are the dimensional analysis can't be given about the proper idea about the. Number two, it is applicable only to the relation which are power functions. It cannot be used for the examples for derived relations to check equations involving trigonometric and exponential functions. If there are sine, cosine, or logarithms or exponential, that means the exponential one, e to the power ln. So we can't just write it. That is a failure about that. Third one, it cannot be used to derive the relation if the physical quantity depends on more than the number of fundamental quantities. That's a quantity in mechanics depends on